Today we're going to get started with our new lesson, the least common multiple. If you remember in the last lesson, we learned about finding the greatest common factor. And when we did that, we were using our factor trees. Well, just as I promised, we're going to be using them again. Before we get started, let's go over our vocabulary terms for this lesson. First is the word multiple. And a multiple is the product of a number itself and any non-zero whole number. So for instance, multiples of 5 would be 5, 10, 15, 20. So we're talking about the answers to times tables of a particular number. A common multiple is just what it means, common. A multiple that is shared by two or more numbers. So for instance, the number 24 is a multiple of both 4 and 6. So it is a common multiple of these two factors. Our third term is least common multiple, and it is exactly what it sounds like, the least of the common multiples. So just a second ago when I said that the number 24 is a multiple of both 4 and 6, and that's true, 12 is the least common multiple. It means of all the multiples of 4 and 6, 12 is the lowest. And then our fourth term is lowest common denominator, which really is just another name for least common multiple, except that this is a fraction term. We use the least common multiple of the denominators. Now before we get started with our examples, what we need to do is go over some steps. There are two sets of steps within this lesson, and here's the first. These rules apply. These steps are used only when you are finding the least common multiple of two numbers. Our first step is that you need to make your factor trees. Our second step is to list the prime factors in ascending order. Now this should be very familiar to you because this is the third lesson in which we have seen this step. Third, if there are monomials that you're factoring, then you have to, after you list your prime factors in ascending order, you need to list the expanded form of all your variable terms. And remember, those are kept in alphabetical order. Then you will circle the factors that are common. So up until here, you have an even number 5. Then you'll take those common factors and put them in a multiplication expression. These first 5 steps are a review for you because these are the exact steps that we followed in the previous lesson, finding the greatest common factor. And here is where the difference is. There is an extra step before we evaluate. Once we have identified and circled our common factors and put them in an expression, we need to then take all the other factors from our list, from our rows, and include them in our expression. After you have all the factors listed, then you evaluate. And this will become clearer as we follow these steps to solve our next 2 examples. 3. So our first directions, find the LCM, least common multiple of 20 and 16. So our first step is to make our factor trees. 20 is found by multiplying 2 and 10. 2 is a prime number, so I'll bring it down. 10 is the product of 2 and 5, so I have 3 prime numbers. 16 is 4 times 4. Neither of these is a prime number. 4 is 2 times 2. 2 times 2 again. Now we have our prime factorization. Our next step is to list our factors in ascending order, and this is how we do it. The factors of 20 are 2 times 2 times 5, and of 16, 2 times 2 times 2 times 2. And remember, we want these rows one above the other so that our next step is easier. Our next step, if you look at your notes, is to circle what the common factors are. Since we don't have, these are not monomials, we're going right to step 4. Both the 20 and the 16 have two 2's in common. So underneath here, we will start our multiplication expression, our two 2's that are in common. Then our following step is to then include these remaining factors, these factors that are uncommon. So we have a 5 and two more 2's. Our last step is to evaluate. 2 times 2 is 4. 4 times 5 is 20. 20 times 2 is 40. 40 times 2 is 80, which makes the least common multiple of 20 and 16, 80. Now in our second example, we have monomials. We need to find the least common multiple of 28x squared y to the third and 70x y squared. Now when you work out this problem, you will make your factor trees, but for the sake of time and space, I am going to skip right to the next step, which is listing the factors in ascending order. The prime factors of 28 are 2 and 2 and 7. And the expanded form of our variables is x times y times y times y. Next, our next monomial, the prime factors of 70 are 2 times 5 times 7, and then the expanded form of our variable terms, times x times y times y. Following our steps, we'll now circle what we have in common. Both of these monomials have a 2 and a 7. They also have an x and two y's in common. So I'll start my expression. 2 times 7 times x times y times y. And now here's the part where it could get tricky. That's why I like to underline. We want to make sure we have our 2 included, our 5, our x, and our y. Because remember, we have to first write our expression using the terms that we circled, the terms that are common. Once we've identified and written all those, we then go back to our rows and we list all the remaining factors. And now it's time to evaluate. 2 times 7 is 14. 14 times 2 is 28. And 28 times 5 is 140. Now we'll move on to our variable terms. Remember, those are in alphabetical order. X times x is x to the second power. And we have our 3 y's that when we multiply them, make y to the third power, making our least common multiple of the monomials that we have here, 140 x squared y to the third power. Now we're going to take what we just learned about determining or obtaining the least common multiple of two numbers and apply it to comparing fractions. Here we have to compare 5/12 and 4/15 and see which fraction is the greater. So the way that we do that is, in following the steps, we take our denominators. Our first denominator is 12, and our second is 15. Because if you remember from our vocabulary terms, you use the least common multiple to get a common denominator. You can't compare fractions like this unless you have a common denominator. So, as I said before, least common multiple, lowest common denominator, they're synonymous terms. Once you do your factor trees, you will get the prime factors of 12 to be 2 times 2 times 3, and the factors of 15 are 3 times 5. Following our steps, we identify what they have in common. It's a 3. So we'll start our expression. And now we need to take the remaining factors. We have a 2, another 2, and then a 5. Now when I'm multiplying, you can either move from left to right. You can take it one step at a time the way I do, or because of the commutative property of multiplication, you can even jump around a little. What I mean by that is I recognize right away that 2 times 5 is 10. So multiplying 2 times 5, we get 10. 10 times 2 is 20. 20 times 3 is 60, making the least common multiple of these two fractions 60. And we're going to use this number 60 to make equivalent fractions so that we can compare. This will be our common denominator. So what I'm going to do, now that you have this copied already, is I'm going to erase and make some space. I will rewrite our original fractions. We have 5/12ths and 4/15ths. And what we're going to do is make these equivalent to fractions that have 60 in the denominator. And what we're going to do is we're essentially going to multiply each of these fractions by the number 1. But that 1 is going to look like a fraction with the numerator and the denominator being identical. So we ask ourselves, how many times do you have to multiply 12 in order to get 60? And you know that that's 5. 12 times 5 is 60. And as I said, we are going to multiply 5/12ths by 1 because we're not changing the value of the fraction, we're just changing the way that it looks. So our denominator has to be the same as our numerator and vice versa. 5 times 5 is 25. So 5/12ths is equal to 25/60ths. And we'll do the same thing on the bottom. We'll see that 15 goes into 60 4 times, which means we're going to multiply 4/15ths by 4/4ths. 4 times 4 equals 16. So that means that 4/15ths is equal to 16/60ths. So now, just so I can make sure that I'm doing the right thing, answering the right question, I go back to my directions and see we need to find a fraction that is greater. 25/60ths is more than 16/60ths, which means 5/12ths is our greater fraction. Now, before we go on to our fourth example, here is that second set of steps that I mentioned a few minutes ago. Because in our fourth and final example, we are going to be comparing 3 numbers, and the rules are somewhat different. The beginning, so here the title is Steps to Finding the LCM, the least common multiple, of 3 or more numbers. And the first several steps are exactly the same. You're going to make your factor trees. You'll list your prime factors in ascending order. Now here is where it gets different. So for right now, what I want you to do is just copy them. And even though it'll be confusing, just be sure that when we work these out in an example, you will understand them better. So our third step, starting with the lowest factor, see where it is used the most, and then you'll draw a box around it or them if it's used more than one time. Next, you're going to cross out the others of the same factor. You'll repeat steps 3 and 4 for all the other prime factors that you have listed in your row. Then you're going to write an expression, and we'll evaluate. And so we're going to use this problem to follow those, we're going to follow those steps, pardon me, to answer this problem. It's pretty involved. I'll explain everything, you'll copy everything. You'll see how these steps work. So order the fractions from least to greatest. Now, what we have to do with these fractions is similar to what we had to do with the fractions in example 3. Whenever you're comparing fractions, you need to have a common denominator. That you learned way back in 4th grade. Now I see that I have 2 improper fractions and a mixed number. So the first thing that I need to do is to take that mixed number and turn it into an improper fraction. So I'm going to change my 3/16 to 19/6. And now what I see is that I have 6, a 45, and an 18. Those are the denominators that I need to compare. Those are what I need to use to find the least common multiple of those 3. So I'm going to list my factors. 2 times 3 is 6. The factors of 45 are 3 times 3 times 9. And then the factors of 18 are 2 times 3. Oops. This is quite a mistake. 3 times 3 times 5. And then the factors of 18 are 2 times 3 times 3. So this part you already know very well. You've been doing this for a couple of weeks now. Now if you take a look at the steps that you just wrote, you see that we've done step 1, well, I skipped step 1, and step 2, listing the factors. And the next step, it says starting with the factors, starting with the lowest factor, identify where the factor comes up the most. So let's take a look at our prime factors. We have 2's, we have 3's, and we have 5's. When I say start with the lowest factor, I mean the lowest prime factor, which is 2. Now we see that the number 2 here is used 1 time, and it's used down here only 1 time. What we're going to do, since it's used the most often it's used is once, I'm going to draw a box around this 2, and I'm going to put it over here. We don't need this one because it comes up the same number of times as that. Our next factor is a 3. We have 1 3 over here, we have 2 3's here, and 2 3's with the 18. The factor 3 is used the most twice. So I'm going to put those over here in my expression. Where it's used only 1 time, we don't need it, so we cross it out. Where it's used twice again, we don't need it because we have it, so we cross it out. Our next prime factor is 5, and that only appears 1 time with the number 45. So we will include that term in our expression. Now that we have followed all the steps, it's time to evaluate. 2 times 3 is 6. 6 times 3 is 18. 18 times 5 is 90, which means that the least common multiple, also the lowest common denominator, is going to be the number 90. So now what we're going to do is we are going to come back to our original fractions. We have 19/6. We have 139 over 45. And we have 55 over 18. Now, I'm concerned that might be too small, so I'm going to do what I did before and erase. Now that you have all that copied, and we'll do our last piece. 19/6, 139 over 45, and 55 over 18. And we are going to make each of these three fractions equivalent to having a 90 in the denominator. Since each of these denominators is less than 90, we know that we are going to multiply every fraction by 1. 19 over 6 is going to be multiplied by 15 over 15 because 6 times 15 equals 90. And now what you're going to do is you're going to multiply. Over on the side of your paper, you multiply 19 times 15. No calculators. 5 times 19 is 95. Then we have 19. We get an answer of 285. Next, we are going to multiply 139 over 45 by 2 because 45 times 2 is 90. 139 times 2 is 278. And our last fraction, 18 times 5 is 90. So we'll multiply 55 by 5, and we will get 275. Now that we have made all of our equivalent fractions, we have to go back to our directions to see that we have to order these fractions from least to greatest. So here, now that our denominators are equal, we look at our numerators. 275 is the least, which means 55/18 is the least. Next, we have 278/90, which is 139/45. And finally, we have our 285/90, which, if you remember, was a mixed number, 3 and 1/6. Now, I admit, this is confusing, especially when finding the least common multiple of the three numbers. I think that once you get that, this part is not too challenging for you, but we will do more practice in school and in your homeworks. All I ask is that you trust the process, follow the steps, model what I've been doing, and you'll be successful.